Hello everyone, welcome back again. This is the Revit BIM tutorial series, and in the last video I took you through how to create your grid lines and your levels. So this is what we had for the grid lines, and we'll go to our levels. This is also what we had, and at the end of the video I mentioned that you should try creating the foundation level at a depth of 1200 from the ground floor. Now, just for the sake of the people who probably weren't able to do it, I'll delete mine. So I go to architecture, go to level, click here, pan to the right. I rename this as foundation level. I change this to negative 1200. It's negative because the ground floor is at level 0. So if we go below 0, it's a negative value. Yeah. And I can extend my dimension so that it now shows 1200. Now you realize that it is showing as black, and that's because we don't have a plan view for the foundation level. You don't see any plan view here. So what we can do is we can go to view, go to plan views, select floor plan, and foundation level is already here because it's the only one without a plan. And go to OK, and as you can see, it's been added. We're in the foundation level plan. Alright, so let's get straight into it. We're going to start with adding some walls, some doors, some windows, and you look at columns as well. So to add a wall, go to the wall option over here, and the architecture, we click. Now by default, Revit gives us a couple of various wall types. So all of these are different wall families that we can use. I see foundation, I see generic, I see interior, but I want us to use the generic wall family. So generic 200 mm, this particular one, because we are going to use this for the exterior walls. I think 200 mm is fine. Now, before we place the walls, I want us to take a look at the constraints tab, right, under properties. What we see is we have a base constraint and we have a top constraint. Then we also have some other stuff like the base offset and the top offset. And these two are very important when it comes to placing the walls. What the base constraint defines is where the wall is going to start, and because we have already defined our levels, you can select any of the level options here. We want our wall to start from the ground floor and end at the second floor, or maybe in this case we just use the first floor, right? So we want it to start at the ground floor, end at the first floor. So make sure our base constraint is set to ground floor, and as you'd expect, top constraint is where the wall is going to end. So because we want our wall to end at the first floor, we make sure that we select first floor for our top constraint. So if I was to draw a wall right now like this, and we're to go to one of the elevation views over here, yes, we'll see the wall starting at the ground floor and ending at the first floor. But aside these two main options, we have some others, which are the base offset and the top offset. Now think of the offset as an extension beyond the constraints that you selected. So if in this case I say that the base constraint is the ground floor for this wall, but I don't want it to start at exactly the ground floor level, maybe I want it to start slightly above the ground floor, what I can do is enter an offset value here. So the wall will be offset from the floor by that value. So if I put 1000 here, you can see that even though I specify ground floor as a base constraint, right, the wall didn't start there. It started at the offset value. If I use DI, I measure, you see, it's 1000 above the ground floor level because that was the offset I specified. But I want to take this back. Now the same happens with the top offset. If I put a top offset value of 1000 here, you see, even though I specify the first floor as the ending point, it went beyond there by the 1,000 value, as you can see. So I press escape. Let's go back to 0. Now, a scenario where you'd really see this being used is if you have something like a parapet wall or a fence wall, right? Some of these walls usually don't go up to the very next floor, right? They will be somewhere in between. It wouldn't make sense for you to add a whole other level, right, for the fence wall, because it will start to make your drawing look a bit too busy. So what we can do is we simply define the wall like this. Then where we have the top offset, instead of specifying a positive value so that it goes up, we specify a negative value so that it comes down. So if I enter negative 1,000, you see it goes below the first floor level by 1,000. So if I measure right now, yes, the wall is below the first floor level and it has an offset value of 1,000. Let's change this back to 0. So let's go back to ground floor. We can even delete this wall for now. One thing I want us to take note of is the fact that before we start placing the component, we have to make sure that we are in the right discipline for the kind of work we are doing, because some elements will not show if you are in the wrong discipline. So if I was to set this to architectural and I start drawing structural components, the structural component will not show no matter what, unless you change some of the view properties. If I was in architecture, if I was in structural, right, as my discipline, and I started drawing architectural stuff, they wouldn't show over here because my discipline is set to structural. But in contrast, you can use coordination. So coordination combines all the disciplines. You see everything on the sheet, right? So whether or not you want that, you can choose that option, or you choose a specific discipline that you want for this particular plan view. So we are going to stick with coordination just so that everybody can see everything. And we are going to start drawing our walls. So we are using the generic 200 mm wall. I can click here, click here, click here, click here, come up here and click. And we already have the ground floor and top constraint set to first floor. So if we look at it in 3D, it's looking nice. Yeah, we are getting somewhere already. Now I want us to also draw some inner walls, right, interior walls, but I don't want us to use the same 200 mm dimension. See if we measure this wall. Good. So another thing we should take note of is when you are measuring stuff like walls, so like the thickness of the wall, you notice that the dimension tool snaps to the middle of the wall. It doesn't allow you to measure from the edge. If you want to be able to measure from the outer face and the inner face, what you can do is you come close to, so with this one I come close to the inner face and I press tab. When I press tab, you see that now that inner face is highlighted, so I can select it. And to select the outer one, I do the same thing. I come close, press tab, and I can select it. So we have confirmed that this wall is 200 mm thick. But like I said, we don't want to use 200 for the interior walls. So what we'll do is to select wall, and we still want the wall to be a generic 200 mm wall, just not this particular. We want it to be a generic wall, just not this particular 200 mm wall. So what we can do is we can edit this existing 200 mm wall type and create a new one that is 150 mm thick, right? So we click on edit type over here and we see this type properties window. Now, like I said, we still want to have 200 mm walls while also having 150. So if we were to edit this very one here, it will change all the 200 mm walls to 150, but that's not what we want. So what we'll do is we'll duplicate this 200 mm wall, And over here, Revit is asking us to enter a name for the new wall type that we are creating. So we'll name it 150 mm. You delete the 2, go to OK. So now we have created a 150 mm wall type, and we need to edit the thickness of the wall. As you can see, at width is showing 200, but 150. So you go to structure over here and we click on edit. Now under edit, you should see thickness, right? And the value is set to 200, but let's change it to 150, which is what we want. And we go to apply over here, go to OK. So now we have our 150 mm thick walls. We can start drawing. As you can see, it's over here, generic 150. So you can start drawing. I'm going to draw a wall that goes all the way down here. And I press escape. After drawing that one, come to this side, draw, come here, draw. And I do the same over here, like this. So we now have 150 mm interior walls and 200 mm exterior walls. Okay, so if for any reason you wanted to select maybe all the 150 mm walls, what you could do is you select one like this, then you right click. So you right click, then you look for select all instances, this particular option, and you have two major options to choose from. That is options visible in view or options in the entire project. If you choose options visible in view, it will select the 150 mm walls that are visible in the ground floor plan, right? Only the ground floor plan. But if you were to select all instances in the entire project, it will choose maybe instances of the 150 mm wall on the ground floor, on the first floor, to any other level. As long as the wall is a 150 mm wall, it will choose it. But in this instance, because we have only the ground floor having walls, any of these two would work. So if I choose visible in view, you can see that it selects all the 150 mm walls. So if you wanted to delete all of them, you could just delete simply. I could do the same for 200 mm. Select one, select all instances, visible in view, and you can see it has selected all of them for me. Alright, so that is all for wall creation. Let's move on to doors. So I go to architecture and I select door over here. And just like with the walls, we have some options to choose from. Right now, it seems like we only have the single flush door type, right? We can load in other families with different types of doors, but I want us to use this for now. And we have various dimensions. I'll just choose the very last one. Now, with doors and windows, you have to place them in walls. You can't place them in empty space. You can see that even if I try clicking, Revit is not allowing me to place it. But if I come close to a wall, it allows me to place the door if I click. And what you will see is you can place the door either facing the outer side or the inner side. So depending on where you move your mouse pointer, you say outer or inner side. Let me just place it on the outer side. Now, if I was to click on the door, I can change the direction that the door opens to, right? So I can either let it open to, so in this case, it's opening to the right, like this. Or I can use this button, switch it to the left, and it opens like this to the left. If I also want it to open inside, I use the up and down arrows. So I can choose just like that. Just like that. All right, so let's just add more doors. Right, this building has to resemble a living space. The people here would have suffered if they had just one door. So feel free, place as many doors as you want, just to get familiar with how the doors are placed. You can even place them inside. The people need to be able to move through. I think that is okay. Every room has like a door somewhere. Now the same can be done with windows. So I go to architecture, I choose window, and I need to make sure I'm placing the window in a wall. So with windows, okay, so we have more options here. You have the fixed, we have the casement double, we have the double hang. I think I'll just go with casement double and select the biggest option. So I come to a wall, I can choose with direction. I just click, I click, and it's placed. I click, yeah, I just keep clicking at random places. My people need to be able to breathe well, you see. And do that. That's enough windows. Oh, there's no window here. So now another way of creating a new window without having to go all the way to architecture, window, and select the window type is, if you have an existing instance of a type of window you want to create again, you can select it, right click, and go to create similar. You see it? Or I select and I use a shortcut CS. So I select, right click, use create similar, this particular option, or I select it and type CS, and yeah, I can create. So now this place has some windows that people can breathe. All right, now let's quickly go to an elevation view. So like the north elevation. Okay, I think we should create a window here so that I can easily demonstrate what I want to demonstrate. So we create a window here. So I select this one, type CS. Let me create a couple of windows to show what I'm going to do. All right, so I go back to the north view, and let's click on the door and look at the options that we have over here. So we can choose the level that the door is on. If we wanted to move this door to a wall on the first floor, or if this wall went all the way to the first floor, let me show you, all the way to the second floor, I mean. Right, so it says ground, use the second floor. Now if I wanted to move this door to the second floor level, first floor level, I could just do that, right? It would move. Let me quickly move my wall back to first floor. Now we have another option, which is sill height. What this sill height defines is the distance from the ground, right? The ground level or the base level, the distance from it at which the door will start. So if I enter a value like 500, you will notice that my door now starts at 500 from the base level, as you can see. And this is typically how we would have doors in this is typically how we would have exterior doors. We make them a certain height from the ground level. We don't like them being at the same ground level. Else, if there are stuff like floods, if there's like a very minor flood, some little water flow, it can easily enter. And what we'd have is, we usually have some stairs, right? Maybe some 1 or 2 rises, or even 3, leading up to the door. So let me make it 450, and that is it. Now if you choose the window, let me choose this one, you notice that we have that same sill height. So the distance from the base level to where the window is going to start, in this case it's 900. If I was to change to something like 500, you see that the window moves down. If I change it to 1000, you see that it moves up. And there are other options, right? If we go to edit type, you can see that there are other things that we can change. So you can change the width of the window, the height of the window. You can even change the fire rating, a whole lot of things. We can change the material for the various parts of the window. So you can see that we have wood stained, we have glass. If you don't want glass, and maybe for some very weird reason you want the panels to be metal, can change to metal. It's all up to you. But in changing some of these things, you are editing the original family. So I would suggest that you instead duplicate it and you give it a new name. Maybe if you want to create a window that is 1500 width, so let me show you. You make this one 1008 so that it's more visible. 1008. So I've created a new window. Then I change this one to 1008. And yeah, see that this window is now wider than this one. Maybe it's not so visible. If I use a value like 2200 and I rename this to 2200. Yes, so now it's very visible that this window is far wider than this one. So in your own time, just play around with all of these stuff. You select maybe a window or a door. You explore all the options here. Can change the thickness of the door, can change the height, can change the material, right? The door material, the frame material, all of these things. So feel free and do all of that. See, our building is looking nice, but I can tell that something is missing. Two things actually. You need to add the floor. We also need to add columns. So let's quickly add a floor. Now to do that, go to architecture and we select floor. This very option. Now creating floors is a bit different. There are several ways we could use. If we look at the modify tab over here, under draw, we have this line tool. So if you want to create a floor based on lines, right, you have your own lines. Maybe it's not a typical rectangular floor and your floor is shaped like this. You can create a shape like this. But the only thing, right, the major issue is in creating the shape of your floor, the loops must be closed. There shouldn't be any open loops. So you can't have something like this, right? You can't have lines that don't connect. If you do that and go to OK, see, Revit tells you that lines must be in a closed loop. So you go to continue and you can join the lines back together. If I do this now, yeah, Revit allows me to create this weird looking floor. Right, so here it is. Here's my floor. I can delete these lines if I want my floor to be a key. I can even do that. And my key is looking nice. Alright, so I want a key. Yeah, I have my key here. I can look at it in 3D. It's a nice looking key. Now, if you create a floor and you want to edit it, you can simply double click, right? You double click on the floor and you go back to editing the boundary of the floor. You either do that or you select the floor and you go to edit boundary. Once you select the floor, you should see edit boundary over here. So I can click on edit boundary and I'm back in the floor editing tool. Now, aside using lines, you can use rectangle, right? You can use this. You can use a circular one. So there are a bunch of other options. You can try all of them in your own time. But the one I really want us to take note of is pick walls. So the very last option. Now, if we have our walls already created and we want to create a floor that is within those walls, we can use pick walls and it makes the process very easy. So in this case, I will select the outer boundary, right? So I select this wall, select this one, and this one like this. And you can see that it's drawn the lines for us. You see the lines, these purple lines. And I just go to OK and we have a floor. If we go to 3D, Yes, you can see a floor here. At the bottom too, you can see it. Now, if for any reason you wanted to edit this particular floor, you notice that you can't select it. You can't select the floor. Like, if you try going to the edge too, it's trying to select a wall instead. And that's normal. Sometimes the objects that you create overlap. So how we would select the floor is we'll go close to where the boundary is. So the boundary could be here, 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 or at this side. So I come close to the boundary and I start pressing tab. If you press tab, eventually you see that it highlights the boundary of the floor, and to even show, as you can see, saying floors, right? Floors, then you're saying floor generic 150. So that's how we know we are selecting the right thing. And just press the left mouse button, and now our floor is selected. So let's go to edit boundary. Now, sometimes you can have holes in your floor. Say, for example, there's an elevator duct, a hole where the elevator is supposed to be, right? Or if for some reason, maybe there's a staircase installation that you need to do, so there has to be a hole there. All you need to do to draw that hole is to draw the shape of the hole, and it has to be within this major exterior boundary. So if I want a hole over here and I want it to be a rectangular hole, I just draw it like this. If I want other holes at other places, I can just draw the shapes. You can feel free, draw any type of shape you want. Now, the only constraint is when you are drawing these interior holes, right? Make sure that your lines don't intersect. So as you can see now, my lines are intersecting. So maybe if I was drawing a rectangle, I was starting like this, and by mistake this happened. If I was to try to finish my changes, see, Revit to tell me that lines cannot intersect, so I would have to move this line back inside. If your holes too overlapped, you would get the same error, right? The lines cannot intersect, so you'd have to change how they look. If I go to OK, yeah, here we have it. So we have a very odd looking slab with quite a number of holes. I don't know if they're going to use it for swimming pools or something, but yeah, this is what we have. Now, if for any reason you want to still have a bit of the slab inside the hole, so what you do is you just draw the shape of the slab again inside the hole. So like this. You see what I mean very soon. Here we go to the 3D view. You can see that there's a hole here, but there's also a slab inside. So that's how you do that. You can do it quite a number of times. You can just keep adding shapes inside. You'll be getting this effect, right? We go to the 3D view. Yeah, this is what we have. So you can play around with creating floors in your own time. And let me just quickly delete all the interior ones, the interior holes. And yeah, we have our floor now. It's looking okay. Now the last thing we can add is the column. So let's go back to our ground floor plan, and under architecture you look for column, which is right here. Now by default it's giving us this universal column, right? This steel column. That is the only column family that has been loaded up for the project right now, and that's fine. We are going to explore how to add other column types when we get to the structural component, right? The structural model. So we can use this, and you can see that this is one type of the structural columns, the steel columns. If we go to edit type, we have access to a variety of different dimensions. So you can change stuff like the width of the column, the height, the flange thickness, the web thickness, the fillet, so many things, right? We have quite a high level of customization. So you can try tweaking all of these settings, but I'm going to keep this as a default one, and I'm just going to place my columns. Please don't think this is structural design, so you need to be so particular. This for demonstrative purposes. But anyway, you can see that when I try to place my column, it said none of the created elements are visible in the ground floor plan, right? Now, if you see something like this, it's usually because of two reasons. The first one is the discipline, right? If probably your discipline was set to architecture, because that is a structural column, you wouldn't be able to see it. But in our case, you see, our discipline is set to coordination, which means that we should see both structural and architectural components in the view. So the next thing, which would probably be the cause of the error, is the fact that the column was created all right, but probably the base and top constraints were set to values that are outside the ground floor. So if, for example, the column was set to start at the first floor and end at the second floor, you wouldn't see it in the ground floor plan. So let's go to our 3D view. Then we try to investigate. Okay, so yes, I see the column here. So that was what happened. The column was defined to start at probably the foundation level and end at the ground floor level. And because that is the case, we wouldn't see it on the ground floor. But if we were to go to the foundation plan, yes, you can see that our column is showing here. So what we can do is we select this column, go to our ground floor, and we can change the base level and the top level. Now, in changing this, it's always best to start with the top level. So we change the top level to first floor before we change the base level to ground floor. Sometimes when you choose to change base before top, let me go back to, sometimes when you choose to change the base before top, you can run into some errors, right? And yeah, now you see that when we change it to ground to first floor, our column is now showing. Now, to create similar instances of this particular column, we can use copy or create similar. So I'll use copy here. Now I select the middle part of the column, right? I click. This is not structural design, so the structural engineers among us, don't be thinking too much about this. It's just for demonstrative purposes. I click here, then just add some over here too. Yeah, our building is going to be very, very steady. Very, very steady. Alright, so I have added in my columns. And if we look at the 3D view, yeah, you have columns sticking out of the walls, but that's not the point of this video. You just want to see how you can create stuff. I can select one column, I can change where I want it to go up to. Let me see, it's moving. So this is how we add basic stuff. These options are what you want, right? They are the right options, so that your column will show in that particular view. Now, the very last thing I would like to point out, all right, is that when, for example, you are creating your floors, if I go to floor creation, Revit always provides a hint depending on the tool that you are using. So if I go to the line tool, right, I mean the line tool, if you look at this side of the screen, when I move my pointer, it might change. But yes, so you see, click to enter line start point. Revit gives you a hint as to how to use the particular tool. If I click once, see that it now changes to enter line end point, and I can just do that. If I was to use, for example, this arc tool, it will say enter arc start point. I click, says enter arc end point. I click again, and now it's changed to immediate point, right? I drag to the immediate point, just like that. If I'm using, for example, the pick walls tool, showing you pick walls to create lines. So if you select any tool and it feels like you don't know what to do, you can just look for any hint that will show over here to show you how to use the tool. Alright, so this is all for today's video. You can try exploring how to create floors, how to create walls. Just feel free, create any shape of floor, any shape of wall. You can even let your walls go to a foundation level. Just get comfortable with how to customize all of these things. And in the next video, we are going to go straight into the architectural model. I'll be showing us a live project that I worked on a while back. So we'll do both the architectural and the structural models. So see you in the next video.